Welcome everyone to our AIM Sports webinar today. This one is our 200th webinar since we started in March of 2020 with our very first webinar. You can go back and look at it. We have changed quite a bit. We've gotten a little bit better at what we're doing. And that very first one was on downloading data, how to connect and download data. And it still gets very high number of views. Is an important topic, obviously. But that was our number one, and this is our number 200. So pretty cool that we've been able to do this over about the last five and a half years or so. So thanks everybody for coming. Thanks for everybody that we built this community around with these webinars, and it's kind of a small little world that we've created, and everybody helps each other out. We've lots of interactions between folks, and I appreciate you all being here. So it'll be pretty fun. Today we're going to talk about Race Studio 3 and new math channels. Math channel news, I should say. Let me not tangle that up too hard. But there's been a lot of changes in the background. Some of them. Emiliano will talk about some of the stuff that's maybe already gone on in the background that you wouldn't notice about, but fine tuning of some of the code and stuff. And then we'll also have about he's going to talk about some new functions that are available currently in Race Studio 3 Beta, which the brand new version is on the website right now. And if you have beta loaded on your machine, you can it is an update just straight through the beta. Remember, you can load beta and you can load production on the same machine, and they're actually fully separated. So sometimes that's a pain. You got data in one and you want it in the other. You have to actually, like two computers, you have to actually go ahead and re-import it into the other side. But it keeps very clean and distinct lines. It's two totally different installs. So keep that in mind if you want to run both. That's what I do. And I run beta for just my daily analysis stuff because it gets updated quicker. And then the area that where beta maybe gets us in a little bit of a little ahead of the curve is in the configuration side. So if I do any configurations and things like that, I use production. And if I do analysis, I use the beta, and if I do webinars or I do support, I use production all the way when I'm showing other people things. So but that's maybe something that you might want to do. And the icons are just different ones, and a white icon for the production, and it's kind of a gold icon for the Race Studio 3 beta, but they work exactly the same. Beta is just a little ahead in the functionality. When a production update comes, an update to production, generally speaking, it goes exactly where beta is, and then beta continues, stair-stepping up, and then boom, production happens, and they become parallel again. So just keep that in mind. But we're going to talk about that. That's where you can see some of these changes right away. Some of the stuff that Emiliano is talking about. If you want to just stick with production, we're in the final testing of some of these things. It could be 2-3 weeks before production comes out with some of the stuff that you're going to see here today. So thank you, Emiliano, for coming in. I appreciate it. Let me see where, oops, okay. What I'm going to do is I'm going to stop the share of my computer. Emiliano is going to run the entire thing from Milan, Italy, at AIM headquarters, the important place that I'd like to go visit someday, if Emiliano would let me, right, Emiliano? So
we will allow you in.
We would. So I unshared mine,
and it will not be an exception.
Yeah, exactly. I know
we welcome everybody who comes here,
which is pretty cool. We've had people that we have met because of these webinars that have been in northern Italy and have stopped by and got a tour and seen what was going on. So I think that's pretty cool. Okay, Emiliano, you're able to talk a little bit and then share your screen whenever you wish, and we are off and running. Again, thanks everybody for coming.
Okay, hello everybody for starting, and thank you for being here. Thank you for having me here. And okay, we will speak into this webinar about Math Channel's news. We added some stuff, and we did some fixes. Not as many as I wanted, but I think a good number of news are in. Basically, we added into the Math channels. We added new operators because
We're not seeing your screen. If you're sharing it, I'm not seeing it yet.
oh, okay.
There you go.
Let me share
I happen
my
to know that was what the
screen.
first.
Okay.
Everybody else, I happen to know
Okay.
that's what's on the first slide, so I knew what
Okay.
he was talking
Can
about. There you go.
can you see it now?
We are seeing it now. Thank you.
Okay. So as I was saying, we have been adding some new operators, starting from user feedback. So we realized that basically in the channels report we had some operators that were not available into the math channels, and these were important for our customers to display into the plots values that are normally available into the channels report. So we added some new operators. And the same operators that in the channels report are available for different things like labs and for segments where we added the same possibilities into the math channels. So we realized they, for example, the maximum value of a channel, it was only available in the math channels for the session, and now we have been adding it for labs and for segments. We will see live data in a few minutes. But this is the basically the thing that we have been adding. There are some news into the integrals, some new computations, new stuff. I will be describing them in minutes, and then in this webinar we will introduce with more details than what I did in the past, the math channels DLL. As we will see, the math channels DLL is a template project. I mean, it's dedicated to programmers, but programmers are, I mean, kind of people that is starting interfacing our world more and more. And so we are dedicating some stuff for them. Uh, I already spoke about this DLL in a previous webinar. I introduced it. I worked with some people with dedicating them some time, and starting from their feedback, I developed some more documentation, and part of this documentation is what I'm introducing here. Uh, and this, I mean, this presentation will be will be usable also as an introduction to this DLL. Okay, let's proceed with what we did. Okay,
Okay.
report operators. As I told you, we started from feedbacks, and we added as operators in the math channels averages, minimum, maximum. If you are a user of the channels report, you know what it is. What is the average of the absolute value or the average of non-zero values that are fundamental to compute, for example, the percentages of time spent braking, or how much time I work with the throttle, or to, for example, to analyze how the racer uses the steering wheel. We added the percentiles, we added the percentages, we added the variance and standard deviation, and these are all available. I mean, some statistical operators are all available within the math channels, and they all are available for session, labs, and segments within within the session. Uh, I want to spend some words on the difference between percent and percentile. The operators is for the percent is PCT in the whole match channel words, and the percentile is PCTL. It's the name is similar, so very likely someone can make a confusion, and I want to help take this confusion out. Uh, when I use a percent, for example, when I want to know which is the percentage of time spent at full throttle, this is just an example. Or I want to use a percentile when I want to use which are the most common values at which channel work. For example, for the suspension travel, I will introduce an example in a minute to see which are the travels that give me the 90% of the usage of my suspension. And there are different math operators to compute them, and percentile is the one that's dedicated for this. Another thing we added, we called it report integral. In the channels report, when you compute an integral, you keep summing, you keep adding the value of the channel, and you know, in the time plot when you compute an integral, you have a channel that keeps building. It builds because it's the channel value, the result value is proportional to the area of the channel value. In the report, normally where the value you see for integral is the last value for the time slice considered. So it's the last value for the lap or the last value for the segment. So we added an operator to give you the same thing into the math channels, and you will be able to have the maximum value of the integral within an interval for the complete time into the interval. We'll see in a while, and it will be probably more clear than my words.
Emiliano, I think your words are pretty clear about that. This is going to be so powerful when you actually see it. I think you're all gonna be pretty interested in it. Just one last thing as I give you a quick breath. It was mentioned in the chat box, but I just thought everybody ought to know there is something that while you're in Zoom, if you're watching this in YouTube later, you can do it in YouTube as well. But right here in Zoom, if you're here live, and you're missing some of Emiliano's words, he's a long ways away with a little bit of an accent. There is a show captions button, and I turned it on while we've been going here, and it is very clear. So if you want to press that button, it's giving you word for word in almost real time of what we're all saying, so you can actually read along if our audio is not so great. So perfect. I appreciate it, Emiliano. Continue on. I'm super excited
Okay.
about some of these new functions.
I do hope my audio is good now.
It is actually very good nowadays. So.
It's only my accent.
Exactly.
So
and you're excited and happy to talk. So every once in a while we talk faster than what we probably ought to. You and I both.
oh, maybe. Okay, so I'll try to speak slower. Okay. I already introduced the report integral, so let's move on to the next slide. We also introduced, this is, a new function that is called delta integral. It's kind of a continuous integral, and it's computed in a slightly different way from the integral, and it is useful for for a mathematical point of view. The integral, as I told you, it's take these arrows as the sample values. How is the integral computed? The integral is computed constantly adding the area that is within the samples. Okay, and it's a channel that keeps building, as I told you. Uh, the orange one is the representation of the integral result. What we call delta integral is I mean, for the result, we compute the areas of only the delta between second value of the channel and the first value of the channel into the same sample interval. So if you keep building these areas, you can compute the delta integral. It's useful for some math computation when you want. It's called instantaneous variation or something like this. Uh, just to introduce this, you will have the chance to try it and see the difference in computation. Unfortunately, the name delta can be confusing if you think at the delta into the time plot, and it is nothing to do about this. It's only a different way to compute these areas within a channel that keeps building. Uh, another example that I'm doing here in the presentation, and then we will go live and we'll have some more. The max operator. What you were used to see was an operator like channel formula computed like this with this operator max of GPS speed in mile per hour, and it gives you a constant value. Now we have lab max and the segment max. So just take out this max in the function being called and substitute it with lab max and or segment max, and you will be seeing the maximum value of the GPS speed within a single segment or within a single lab. As I was saying here, okay, this is a quick computation made on GPS speed. You will see that I mean, this red one is the maximum value of the speed for the whole session. This blue one is the maximum value of the speed within the lap, and it changes. If you look down here, you see it changes lap after lap. Okay, the maximum grows for the first three laps, then stabilize into pretty much the same value. While you can, in pink here in this image, in this capture, you can see the maximum value of speed computed segment after segment. This has been a long requested feature by many customers. We will see it operating in just a second. One thing I need to say about segment operators it, is that they are not automatically all the match channels that are basing on these segment operators will not be automatically recomputed upon any change in segments. So if you, I'm going back to the previous slide, if you move the segment, if you modify the segment from the time plot, you can do it very quickly, and this operation will not be triggering the match channel recompute. This because when you play with segments, you constantly keep changing them, and you don't want to have a possible time to compute maybe very heavy math channels. So you adjust the segments, or you change them. Switching into the segment selector, and you trigger the recompute of the math channels.
Emiliano, you
These
mentioned that in the for some of you that maybe not haven't used that function a lot. When you do a segment adjustment in your right in the screen. You free those adjustments up. You make an adjustment. Literally everything else in Race Studio 3, from split reports to everything else, gets calculated in real time. So the reason that
Yep.
Emiliano makes a point of that is this is the first time we're introducing something where you make an adjustment. Those math channels are the only thing that's not going to be adjusted until you take the one additional step. But everything else inside the software, which is very, very powerful and very cool, it gets automatically adjusted when you just move and then let go of your mouse. Everything gets readjusted, so it's pretty interesting.
It's very likely that we will move into an automatic computation of the match channels if we are smart enough. I mean, no, there are some maybe some improvements we can still make, but at the moment it's not we don't consider it a big deal because. Normally, you define the segments you want to operate on in at the very beginning of your analysis of the sessions, and then the segment they will stay for very likely the whole weekend. So uh, these these is not a proper limitation according to us. Anyway, they get automatically recomputed when you load the sessions, so you do not need to continuously recompute them. It's just load the next session and they will be recomputed. It's very fast. Okay, this is the last slide I wanted to speak about. So let me end my presentation. My okay,
Yep,
and
it,
let's
it
go to
changed. We can
some.
we can see your Race Studio 3 now.
Okay, okay. So let's go into some live data. I prepared the session. I prepared here a session from Matt at Summit Main, in which I added some of these Matt channels. Yeah, this is the very first here is I created the math channel. Okay, let me show you the formula. It is segment average. Okay, this one. Okay, the formula is segment average of GPS speed in MPH. This is a very basic formula. It computes the average of the speed of the GPS speed channel within any single segment. Uh, very very useful when you compare two laps to get an immediate at a glimpse you can say you can see which is the
Faster of the
zoom
two
in.
segments, yeah.
Yeah,
Very easy.
which is the faster of the two segments. Yes, exactly. uh, Here it's pretty easy to handle because because the in the red lap the speed has been higher. You immediately see that that is higher, but in other there are segments in which it can be not so immediate, and this channel, this operator can help you truly a lot. Uh,
That segment 11 right there really shows the power of, if you zoom in on that one, the green lap was faster and they got on the brakes too early. And look at the
mhm.
difference in the average speed of that segment. The red one was a lot faster, just from going in a little
Yep.
deeper on the braking. So
Yeah, exactly.
interesting.
Exactly. Another operator I created is the percentage. I used the non-zero percentage is percentage of braking pressure within the lap. So this is useful for having an immediate glimpse, an immediate view on how much you use the brakes into every single lap, and it's done normally with the channels report as I told you, but now you have the possibility to see it here, and it's pretty immediate here because the comparison is done in a graphical way. So here. To do this, you need to introduce two different math channels. The first one is to define a condition channel. This because this is computing the percentage only for values of the channel that are non-zero, NZ. And okay, then you see that when you normally operate with the brake pressure, you have a residual value when the brake is released, so it's not completely zero. So you need to define a math channel before using this second operator, and the math channel you need to introduce is very simple. It's what I call a condition channel. So normally I state a triggering value for brake pressure that is 5 bars. I mean, it can be 3, can be 2. Normally, these are the common values. And I say, okay, this channel will equal the brake pressure when it is greater than 5 bars, and it will be zero otherwise. So when a channel that is made like this, I can build over this. I can build the percentage non-zero, that is this one. So I will ensure this operator that distinguish only zero and not zero. I will ensure I will ensure that when I'm not braking, when the brake pedal is released, the channel will be featuring a perfect zero value.
And of course, we
Okay.
have to do that because the Race Studio is very literal. And when it says not zero, if it's 0.001, it's not zero. So we have to
Yeah.
that earlier math channel will make it's one of those tools you'll find yourself using a lot if you dig in deep into math channels.
Yep. Let's move on. I prepared a profile with some examples of these. This is the max operator that I was speaking about. You will see this is the maximum of the session, and it will be constant for the whole session. If you zoom out, it will be always the maximum value of the channel. Okay, let me go back to here. This is the maximum of of the lap. Okay, within the lap, and the same will be applying to segment. Okay. Uh, Same for average. We can do the same considerations for average or for maximum. You can quickly compare segment by segment which was the fastest lap as for maximum speed. Okay. This is the behavior of the difference between the integral value and the delta integ. The delta integ is kind of an instantaneous variation of the channel, and applied. Yeah, we should do some more complicated math, and I didn't want to do it for this webinar, but maybe we will do something more in the next one. Okay. Uh, it is computing in a different way. Okay. Uh, Here I'm showing a possible use for the percentile math channels. So I want to know which are which values of the suspension travel represent the 90% of the usage of the suspension. I can do 90, I can do more, I can do less. Just deciding which are the values I enter in the percentile formula. So when I compute the 95 percentile, I'm saying, okay, tell me which is the value for which 90% of my samples are below this value and 10% of the 95, sorry. So 95% of the values are below this value. 95% of the samples are below this value, and only 5% of the samples are over this value. And the same when I compute the fifth percentile, I'm saying to the engine, okay, now tell me which is the value for which 5% of the samples of the suspension travel are below this value. Okay, this is the 95 percentile value. This is the 5 percentile value. Inside these two values, you can find the 90% of the working of the suspension. These can be very useful for suspensions, for temperatures, and so on. And if I want, I can do more. I can do, okay, now tell me which is 99% of my usage. So I should be building a percentile with 0.005 and 995%. So it's very powerful. Let's see the formula to compute this. Okay. This is the percentile. The operator is a PCTL, and I pass the channel I want the percentile of, and I enter a number that in this case is the fifth percentile. As I told you, it will be giving you this bottom line here. So again, I'm repeating, 5% of my samples will be below this, and the 95 will be over this value. And this operator is computing the exact value at which this happens. I can enter 10, and this line will be a little bit over this, a little bit higher than this. Okay, because a higher number of samples will be below that value. Okay. The same applies to
To tie that together a little bit with a conversation I had just last night, with an engine builder in karting, and one of the things he was really interested in pursuing was he builds his engines for his customers, and they have a known power band, and then they try to gear their carts to spin the most time inside of that power band. And something like this could be easily manipulated to give him a very nice image of, hey, how much time are we spending with this 60 tooth rear gear inside of the power band that as we've designed it. So just another idea of ways of using this function. It'll be interesting.
Yep, exactly. It's another way. It tells you, given a percentage, it gives you a value. You want to in this case, I made it a little bit more complicated because I computed the 95 minus the 5 to have the 90% central of usage of a suspension travel. But I mean, this is very, very, very handy. I think it can be truly useful. The same can be computed for laps. You will have the same operator for laps or for segments. So you can be computing the same suspension usage within a certain segment or suspension or temperature or throttle position or whatever. If you speak with an engine builder, maybe he wants to define which is also the most common throttle position values, because he needs to define a better mapping for the transient, very likely. So he will be for sure taking benefits of these channels. Another use of the max, I introduced this because I don't know if it's that known, but you can use the maximum operator. If you using a max and mean and average, these operators are featuring a double behavior. If you pass to the max operator only one channel, it will be computing the maximum of the channel within the session or within the lap or within the segment. If you pass to the operator two channels, two or more, they can be three, four, five, any number of channels. It will be computing at the same time the maximum value between the two channels. So take for example these. Okay, I have tire temperatures. Okay, let's take one only lap for simplicity. Okay, let's go back to channels. Okay, here it is. 105 and 108 are the values of the two channels, and okay, this is mm, it's an interpolation issue, but I mean, because I didn't get the exact frequency of the original channels. Okay, but you can see uh, the maximum value moves from following one channel to following the other one. Here it is following the red channel, and here it is following the brown channel. Okay, and it computes the maximum within two or more channels. You can use this possibility for computing, for example, the maximum value of speed out of the four speeds at the four corner of the cars, or you can have the same for average or the same for minimum. So you want to compare uh, maybe tire slippage and so on. You can do it with these operators.
Very
Okay.
interesting. Very interesting.
I didn't see if there are any more question about these operators. Otherwise, mm,
Robert Sachs has a long question in there. I'll have to read through it and see if I can get that down to a little bit closer. And we'll see. I'm not sure if you can read that or not, but go ahead and explain this. What you graph here, I'll try to bring together Robert's question.
okay. Pretty much okay with these. I added the channels report page just to witness that we will have all the operators that are available here. The only one that are not available are time of minimum and time of maximum, because they can be computed. They can be computed, and the drop is only available in the channels report. Uh, as I told you, when you move a segment to have a quick recompute of the channel, just open the channel settings window, recompute, exit, and that's okay. It's immediately adjusted by the engine. What else? Okay. If there is no question, I'd move to the Matt channels DLL. It will take me around 10 minutes. I mean, I have a Roger.
Yeah, I wanted to kind of go back real quickly to Roberts just before you jump out to that.
Okay.
The DLL is going to be a very interesting discussion. There's a lot of slides, and it's not for everybody, but it's but it's going to be a powerful tool for some of you. So it'll be interesting to do that. Robert asks, is there a way to compute an average lap? In other words, take a set of laps and average, say, the speed at all the sample points to generate a lap trace. So he wants to combine the lap trace multiple channels and just have a single smooth line. Is that what the average function that we've just talked about will do, or
No, this is another step that is requested by the feedbacks, the possibility of computing math channels between labs. This is another step that we are evaluating. It's from a concept point of view, it is close to what we do into the time compare. The time compare is built this way. It's a comparison of values between channels, and here is the result of the comparison. We don't have it now for other channels, and we are evaluating this possibility.
how to do that? Okay,
I
perfect.
understood what is needed, and
Okay.
I understand why it could be needed, but at the moment, no.
Okay. If we're seeing your screen now, if you wanted to, I don't know if you want to jump back to the presentation to go for the DLL information, or if there's something else you want to cover in Race Studio 3.
No, I think I'm okay with Race Studio 3. Okay, so let's go for the presentation. Okay, here it is. Should be coming.
There it
Okay.
is. We see it. We see it. Go ahead.
Okay. Few words. What is the DLL? I mean, the DLL, we are speaking of the possibility of creating a Race Studio 3 plugin. And this plugin will allow you to create all the channels you need, all the channels you want. You need to be a programmer to code this, and it does not require any license or any licensed software. There is a fantastic software by Microsoft that's named Visual Studio Community Edition. It's free for personal use, and you can use it. You can use it with proficiency. You're not. It's not mandatory to develop that. You can also use other IDE without any issue. Uh, just before any other question arises, uh, we already have another DLL that is used by other software, other pieces of software. It's a DLL we distribute. That one is a DLL that we distribute for allowing people in their coding, allowing them opening our data files with our proprietary format, and to take samples out of our files. That one has this aim. This one is a thing you create to make a plugin for Ray Studio 3. What can you do with a DLL that is not possible with math channels? Basically, with a DLL, if you build math channels within the DLL, you are not sharing the formulas of your math channels. I know that many coaches, many of our customers who train other people, they do not want to share their intellectual property because they build on that intellectual property. They build their career. They build their whole job, and the DLL allows them not to share any formula with other customers, and you can also, using the DLL, you can also apply the computation to a specific logger. So you can work for a customer. You can, as a developer, work for a customer and develop a math channel only for his logger. And the same math channels will not be working for another customer unless you want to. Uh, few slides just to detail the installation very quickly. I mean, this presentation will remain as a quick introduction. I just point some words on few details that will fix any possible issues since the beginning. You will need the DLL. It will be the DLL template project, and it will be available on our website very soon. Very soon means tomorrow or 2 days from now. Download and install the Microsoft Visual Studio IDE, the development environment. During the installation, as in the following slide, you need to flag a specific area of what you are prompted to allow for the development that the kind of the development that we need. I'm jumping back to the previous one. And when you extract the template project we supply into a folder, you will see that there is a math.dll.sln, that's solution file, and it's a file in the Visual Studio format. Double click on it, and Visual Studio will open it very quickly. The structure of the template project is very simple. 10 files roughly. Double click on the file and you will see the source code of the DLL. Just take an attention to choose the release configuration for the DLL. Build solution, and you will be building working a working DLL. When you build, you will be prompted in this output window. You will be prompted the folder and then file name of the DLL that has just been built. You don't need you just need to remember this path and use it within the Ray Studio 3. Within the Ray Studio 3, you will notice this icon. Click on this into the Math Channels application window. You will notice this icon. Click on this. Here you will find an import button. Just remember the path in which the DLL has been built that was shown you before, and you will see this DLL. Click open, and the DLL will be within the Ray Studio 3. Using the properties icon, you will be able to check what's in the DLL and see if it's working or no. Here you will be prompted any mistakes or errors, and that's it. I mean, the DLL will be computing all the channels that you created in just few seconds, faster than what's in the math channels if you are a programmer. As I told you, the template will be generating a DLL named AIM example. There is a way to rename it. Here is the way to do it. Right click on the project, select properties, and change the name. So you will be using the name you want. And few very limited words on how it's called, on how it's coded. There's a main file named math.dll.h, and in that one you will be seeing the complete help of every function that is called by the Ray Studio. I mean, you are creating a project, a piece of software that is invoked by Ray Studio 3, and Ray Studio 3 is calling the function you write here if you respect the correct format. The functions will be just as a quick hint, I advise to look for the init function in which you initialize the channels you write, the channels you code. I added the two example channel and some bad channels to represent which are the possible errors. And yeah, this is the basic structure of a channel in which you can write in this is the part in which you can write the code you want. I know this can be a little bit out of target for the webinar, for this kind of webinars, but it's a thing that is I think I've been asked many times from programmers, and so here is the reason for which it's now being introduced into this webinar. Uh, what else? For the DLL, very likely we will be doing a dedicated video, just not to take too much of your time. And that's it.
I
I mean,
think it's fantastic to give everybody a little bit of an idea of what the program is capable of. And even though person like myself, I'm not probably going to be a programmer, but once I know that that possibility is there, either when I can go learn about it and maybe dabble in it a little bit, or even probably more typical will be, somebody on our team or somebody I know, or we can, hire somebody that can do certain things for us. So presenting it here and briefly going through the slides like we did, I think there's value there to just to let everybody know that it is a process that is out there, that is available. This is something that could very well be of use to people. So I appreciate it, and I hope everybody else did as well. So anything else you'd like to add before you unshare your screen, and then we will kind of
uh,
finish up.
I I think I'm okay with the presentation. If we are okay with the live data, I think I can stop sharing my screen and
Yeah, I've been watching the chat, and the live data was very well received, to tell you the truth. So very cool.
okay.
Okay, let me jump in. Let me make sure I'm on the right page here. Boo boo, share, and to do. There we go. The I hope some of you got some good out of that. The 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 numbers of new math channel functions that are going to be available to you today in Ray Studio 3 beta, if you were to go grab that, or in Ray Studio 3 production in a few weeks. Emiliano only talked about probably 3 or 4, maybe 5 math channel functions. There are a lot more than that. Virtually every one of those has a do it by the lap, by the overall, and by the segment, right? So you've already got 3 times more than what some of what he showed. But there's a lot of new functionality in the math channels. Emiliano, maybe you can add just a little bit before we jump out totally.
Yep,
But
sure.
you've made some kind of some hidden process improvements deeper in the math channel functionality. You want to talk briefly about some of the stuff you've done behind the scenes that is already in place, that's for speed and precision and accuracy and some other things?
Yeah, I mean, we improved the code to use double precision floating points instead of single precision, and it pays. We switched to double precision because with the 64-bit processors, it is faster. And I think we sped up the math channel engine a little bit. We also worked you mean some there are some channels that are for example the lab integral that previously was not managed correctly, the last sample of the lab or the last sample of the segments, and we fixed it. So there are hidden improvements that, as you say, can can make life easier, or can reduce the cases of minor issues that are minor, as I said, but they are disturbing. And so we tried to fix all of them, and I think the job is done.
Yeah, I just wanted everybody to understand that while they may look at the release notes and it may say minor bug fixes and improvements or something like that, right? And a lot of that happened to tie into with today's video where we were talking about math channels. There, I know there's been a lot of work that's been behind the scenes that doesn't show up in the release notes, and I just wanted to let everybody know that there's you guys are always
We
working
also
and fixing things.
Oh, we also worked on the preview window. We
Yeah,
made it a little bit faster when you switch from one session to another one. Uh, this avoiding to load some data that is not useful. So we constantly try to optimize according to feedbacks what is our job. Programmers are lazy, and so very often we say, okay, we need to load the session, and we load every kind of stuff that is possibly related to the session, and this takes time.
yeah,
So then we go avoiding some part of those, and we can make things quicker. We did it according to feedbacks as we usually do. Uh, and and
very much so. And some of the feedback. The reason I enjoy that is that some of the feedback that he's talking about is Roger whining about certain things. So it so I come on, speed that up a little bit if you can. What can we do? So, but anyway, I appreciate all the work you guys are doing, and I hope everybody else is seeing that. Not just the math channel functions that he talked about today, but there's in the math channel area, there's been a lot of improvements as well. So the as we kind of close this one down, the video that we're recording right now will go up on YouTube right away. Those of you that are watching this on YouTube, we've talked a little bit about links, and there's been a bunch of links and stuff that we've been placing into the live chat with the folks that are here with us. Those will all be in the description down below. So if you hear us mention anything, or you think, well, boy, I wonder if they had any other links that they talked about and provided in the live, just go down in the description there, just below the description of of this webinar. You'll find a link of all of a list of all of the links that we thought we were going to provide and probably did. So that's for you, those of you watching this later. So we'll get this one up there as soon as we can, probably be within an hour or two, and give all of that information. So go visit us at our YouTube site and subscribe and get notifications on all the different videos that get placed up there here after our 200th webinar. The customer support, boy, we are in the middle of the racing season, in the middle of summer, and we have technicians running around, and everybody is running as fast as they can, and there are as many events as we can cover, and it's a crazy time, but we're out there. If you see the folks out there, make sure you ask for any help that you might need, and that's what we're out there for. So looking forward to it. Our next AIM webinar, July 8th, Tuesday, in the later evening here in North America, 6 p.m. Pacific, 9 p.m. Eastern. We're going to have Eric Prill from SCCA. He's the SCCA Vice President. He's a long-time road racer, and a picture of him racing and winning the runoffs there. I think that was at Indianapolis, and the big AIM user in all of his race cars. And we're going to talk about SCCA and road racing, and a little bit of background on Eric. Plus, the SCCA has a large program in place where they use AIM solos for balance of performance. They put them in all the different cars at all the large events, and people then analyze that data, and they try to figure out how to make sure everybody's good and fair across all the different current makes and models of cars that are in different classes. So Eric's going to talk a little bit about that, and we'll also talk a little bit about alternate start-finish lines that SCCA is using a lot of their national events now to speed up qualifying and practice and some other things. So we'll talk a little bit about that and how that affects folks in the data side. So look forward to seeing and chatting with Eric Prill July 8th coming up in our next webinar. So the contact information, we've gone through a lot. And if you have more questions about the DLL or some of the different math channels that you have, there's a couple of contact emails down there below, so you can get a hold of folks and ask some questions. And boy, I look forward to even more additional math channel functionality. And as Emiliano mentioned earlier, we'll be doing a standalone video on the DLL here shortly, where Emiliano and I it will not be a live webinar, but we'll record it and put it up onto the website with much more detail about a lot of the stuff that Emiliano briefly talked about today. So I appreciate it. Thanks everybody for coming. Thank you,
Thank you.
Emiliano. Anything else you kind of like to add as we're kind of closing this one up?
As usual, I thank you all for being here, for pushing us, improving stuff. Truly appreciated.
Yeah, absolutely, and thank you for all you and your team for all the hard work that gets done. It's very appreciated. I went back and watched a video. Somebody asked a question about our very first webinar, so I ended up watching that again and to grab some information. And it was the amount of change in Race Studio 3 in 5 years has been absolutely tremendous. So all of it in a positive direction. So thanks to all of you and your team for what you're doing. So thanks everybody. Thanks Matt in the background for putting up links and taking care of some questions as we were going. We appreciate that. And thanks everybody for showing up that was here live and for watching on YouTube. Look forward to seeing you at the next one, and we'll see you guys all later. Talk to you soon.